In this session, I will explain about root mean square value. The RMS or root mean square value of an effective value of an alternating current is that steady current which, when flowing through a resistance for a given time, produces the same amount of heat as is produced by alternating current flowing through the same circuit for the same time and produces the same amount of heat. Consider two circuits having the identical resistance value. The resistance is same in both the circuits, but one circuit is connected to DC power supply and the other circuit is connected to AC power. So this is the circuit which is connected to DC voltage and this is the circuit which is connected to AC voltage. And if the current is passed through both the circuits, it should produce the same amount of heat when both the currents are passed for the same amount of time. Then we say that this alternating current value is equivalent to that steady state current value. That means what we are doing is, this is the alternating current value which we are going to convert it into the steady state value, that is nothing but DC value, converting the AC into DC steady state value. That is done by making use of root mean square value, and this can be analyzed by making use of wattmeters. The two wattmeters are connected here, which will note down the power dissipated, or which are going to note down the amount of heat produced by each circuit. So the basic criteria is to pass the current so that for the same time, so that both the circuits are going to produce the same amount of heat. The heat produced by both the circuits should be same. Then only we say that this voltage which is going to generate a current is equal to the current which is generated by the DC circuit, and that is called as root mean square value, and it is given by I is equal to Im by root 2. Im is the maximum value of the current of this. If we take, this is nothing but the Im, maximum value of the alternating current. That divided by root 2 is nothing but the DC equivalent of the DC circuit. This DC current will be equal to the AC current by this relation. This is AC and this is the DC. And this DC can be represented here from 0 to I. This is Im which we are having in alternating current, and this is the AC current and this is the DC current. So from AC we can convert it into DC by using this relation, that is DC value of current will be equal to maximum value of AC divided by root 2. Now let us derive this equation. Consider a strip of thickness d theta in the waveform shown. This is a waveform, AC waveform, and we have considered an elementary strip of thickness d theta. Then the area of this strip is equal to I square into d theta. I is the current which is flowing, and I square is also shown along the y axis, and theta is along the x axis. And this signal which is shown here, this is I value which is given by I is equal to Im sin theta. That is nothing but only that we have taken here. So area of strip is given by I square into d theta, and we can measure the area of the strip for first half cycle of squared wave. If we take the square of the, this is the current. If we square this current, we will get another waveform which is denoted here, that is I square. Positive into positive, positive, negative into negative, minus into minus is plus. So this value is shown on the positive side. So this waveform is of I square. Now considering the one half cycle and calculating the value of area over the half cycle. So area of half cycle of squared wave. This is given by 0 to pi, because from here to here it is pi. 0 to pi, half cycle is of pi. So 0 to pi into the area, that is nothing but I square d theta. And we know the value of I. I is what? The AC current, which is given by Im sin theta. So substituting the value of I, we get 0 to pi Im sin theta whole square into d theta. This we got because we know that I is equal to Im sin theta. Now this can be further expanded. 0 to pi Im is Im square and sin square theta d theta. Now in this Im square is constant, so it can be removed out of the integration. So this equation will be 0 to pi Im square, and the sin square theta is nothing but 1 minus cos 2 theta by 2. This is 1 minus cos 2 theta divided by 2 into d theta, because we know that sin square theta equal to 1 minus cos 2 theta by 2. We have just substituted the value of sin square theta here. Then from this 2 is constant and it can be removed outside. So this will become Im square by 2 integration of 1 minus cos 2 theta into d theta over the integration from 0 to pi. So this can be simplified as Im square by 2, substituting the value, that is theta minus sin 2 theta divided by 2. This is the value which we got over the integration value of 0 to minus cos theta, we have replaced it by sin to the 2 theta by 2. So this is equal to Im square divided by 2, substituting the upper limit theta is pi minus theta value lower limit 0. This is theta with upper limit minus lower limit minus of this value sin 2 pi is 0 minus sin of 0 is also 0. Now this will be equal to Im square by 2 into this pi, and remaining will become 0. So this is equal to pi into Im square divided by 2. This is what we got, area of strip. Now we know that the current is given by root of area of first half cycle of square wave divided by the base. So area of first half cycle of square wave, we got it as pi into Im square divided by 2. This whole divided by base. Divided by base. Base is, we have taken from 0 to pi. So the base is pi. So this is equal to root of pi into Im square divided by 2 whole divided by base, that is nothing but pi. So this can be written as pi into Im square divided by 2 into the reverse of this is 1 by pi. So this pi will cancel and we will get Im square divided by 2. So this can be further written as Im square, we can bring it out. So it will become Im divided by 2. If it comes out, it can be represented by root 2 only. So root 2 value is 0.707 into Im. So this is the value of the DC current which we got. Hence RMS value of current is 0.707 times the maximum value of current. This is the maximum value. This is the RMS value of current. Similarly, we can express the value of E, RMS value of voltage, is equal to 0.707 times the maximum value of voltage, that is EM. I, we got it as 0.707 Im. Similarly, E equal to 0.707 em. have taken the base as 0 to pi. That is pi minus 0 is pi. We can take even 0 to 2 pi. If we take 0 to 2 pi, the base should be 2 pi only, and then equating all, we will again get the same thing. This is how we calculated or we derived the equation for root mean square value of AC current as well as the AC voltage, which is represented by E. Next topic is to find the average value. Consider AC voltage, which is represented by this. This is the instantaneous voltage, which is shown along y-axis, and theta is shown along x-axis. It is having the value pi to 2 pi, and this is the voltage. And let this strip that is taken be of value d theta. So average value is defined as the average of all values of alternating quantity over one cycle. So it is defined as the average value is the arithmetic average of all values of alternating quantity over one cycle. Over one cycle means we have considered from 0 to 2 pi now. We have to take the arithmetic average of all the alternating quantity values. So let the let alternating voltage be represented by E equal to Em sine theta, and let d theta be the thickness of strip over first half cycle. So area of strip is given by, therefore area of strip we can find, and it is given by E into d theta. So we know that this is the E voltage which is given into multiplied with the thickness, that is nothing but d theta. Now this is what is area of the strip. Now to find the area of first half cycle, area of first from here to here. Area is given by 0 to pi, because we are taking the interval from 0 to pi into the value of that, that is area of strip, which is given by A into d theta. Now if we simplify, we know that E is given by Em sin theta into d theta, this d theta. Now in this, Em is constant, so it can be removed outside the integration. So Em integration of sin theta d theta over the value from 0 to pi. So this is equal to Em sin theta, integration is minus cos theta over the limits 0 to pi. So this can be written as Em minus, if I remove outside, it will be cos upper limit is pi minus cos of lower limit is 0. So this can be further simplified into Em minus cos of pi. Cos pi is minus 1. So this is minus 1 minus of cos 0 is 1. So this can be written as 1. So this is equal to Em minus minus 1 is when both the signs are of the same type, we have to add. So it is 2 with the sign that is minus. So this will be equal to minus into minus is plus into 2. So this is equal to 2 times Em. Now this is area of first half cycle that we have calculated. The next step is to find the average value. Average value is given by area of half cycle divided by base. Average value is equal to area of half cycle divided by base, and we got this area of half cycle as 2 Em divided by base we have taken for half cycle, that is 0 to pi. Pi minus 0 is pi, and if we simplify this, 2 Em divided by pi is 3.142. So this will be equivalent to 0.637 times the maximum value of AC voltage, that is Em. So we got this as average value, which can be represented as E average. E average is equal to 0.637 times the maximum value of AC voltage. Similarly, we can prove for alternating current, which is varying sinusoidally by I average is equal to 0.637 times the maximum value of alternating current. next topic is form factor. We got IRMS as 0.707 times the maximum value. We got I average as 0.637 times the maximum current. Form factor is defined as the ratio of effective value, that is nothing but the RMS value of an alternating current or alternating quantity. If we take it as voltage, then we can say it as the ratio of alternating quantity, that quantity may be voltage or current, to the average value, is called as form factor. The form factor is nothing but the ratio of effective value. Effective value is nothing but RMS value to average value of alternating current, or it may be defined as it is the ratio of RMS value of voltage to the average value of voltage of an alternating quantity. So, form factor is denoted by Kf. Usually it is denoted by Kf, and this form factor is given by the ratio of RMS value, root mean square value, to the average value. So, for sinusoidal alternating current, this form factor is given by the RMS value, which is given by 0.707 Im to the average value. Average value is given by 0.637 Im. So if we cancel these two, it is given by 1 point, it will be equal to 1.11. So this is the value of form factor for sinusoidal alternating current. Similarly, we can find the value of form factor for the voltage also. For sinusoidal alternating voltage, if we consider now the voltage, Kf is given by the RMS value, ratio of RMS value to the average value, that is 0.707 Em divided by 0.637 Em. These two will cancel and the value will be 1.11. So the value of Kf, that is form factor, is always 1.11. It may be voltage or it may be current. So how we are going to express this is form factor, which is given by Kf, is the ratio of RMS value to average value, and this is equal to 1.11 times the RMS value will be 1.11 times its average value. The RMS value will be 1.11 times its average value. So this is how we can define the form factor. And the last topic that is left is crest factor, peak factor, or amplitude factor. amplitude factor. The thrust factor, peak factor or amplitude factor is denoted by Ka, and it is the ratio of maximum value to the effective value of an alternating quantity. So Ka is given as the ratio of maximum value to the r.m.s value of an alternating quantity. Again, that alternating quantity may be either current or it may be voltage. So let us consider for current. For sinusoidal alternating current, Ka is given by maximum value. For current, the maximum value is denoted by Im divided by the r.m.s value. The r.m.s value we got it as 0.707 Im. So this Im will cancel. So the value of Ka is 1.414. 0.414. So this is the value of Ka, that is 1.414. Similarly, we can find for voltage. For sinusoidal alternating voltage, Ka is given by the maximum value. Maximum value is given by Em. Maximum voltage is always denoted by Em divided by the r.m.s value. R.m.s value is given by 0.707 Em. This Em will cancel, and its value will again be 1.414 only. So this is fixed for both current as well as for voltage. Thank you and subscribe.